Hello everyone, welcome back to my YouTube channel KK Avasthi Edu Hub. In today's class, we are going to discuss household circuit. This session is strictly as per ICSE class 10th curriculum, and we are going to cover the entire chapter in two parts. This very first part deals with the transmission of power and house wiring. This chapter holds a weightage of 4 to 6 marks in your board exams. I'm talking about boards 2025, and nothing is reduced from this chapter. Let me be very clear about this, right? Each and everything mentioned in Selena is indeed in your syllabus. So let's start the session. The first part deals with the generation and the transmission of power. See, the power is generated at power station. And how is it generated? In this particular diagram, it is clearly mentioned that you have boilers through which some steam or energy would be generated, and that energy would be moving the turbines, and by the movement of that turbines through generators we'll be generating electricity. This particular part was also discussed in class 9th physics, heat and energy, right? If you guys remember, the energy part covered the generation of energy. You have already studied geothermal energy, hydropower, a lot of energy constraints, a lot of energy methods in class 9. So we are not bothered about how this energy is generated in class 10th. You simply need to understand that there will be a power station, and this power station will be generating energy. Now, what needs to be taken care of? You have to remember that this energy, this power is generated at 11 kV. Now, a very basic question might arise ki, sir, why 11 kV? Why not 20 kV? Why not 100 kV? What is unique about this 11 kV? So let me explain you why we generate it at 11 kV and why not at some other value. See, first of all, these generation and transmission norms are fixed and they vary region to region. In our country, 11 kV is fixed for generating power. Maybe in some other country, the standard will be different. Okay. But why 11 kV? Why a low value? Why not a high value? That is a major question. Okay. So just go through the slide. It's clearly mentioned that you have generated the power at 11,000 volt and a frequency of 50 hertz. Please remember this, that the frequency at which this power is generated is 50 hertz. Now the very basic question, why aren't we generating power at a very high value? See, if we are keeping V high, a lot of students get confused. They use V is equal to IR and they believe that V is high, I is high, R is constant. But this is not how you will be decoding this concept. See, you always keep the power constant, right? You have to generate electricity at a given power. You cannot change the power. So here we'll be using this particular formula. If we keep power constant, then V is inversely proportional to I. Now just tell me, if I keep the value of V high, what will happen? I will become less. And if I becomes less, we know that heat generated is I square RT. So a low value of I will account for less losses. We need to keep a check on the losses as well. See, generating electricity is okay. It's not a major concern. The major concern in any system is the transmission of power, because that is where maximum energy is dissipated. So we need to keep a very tight check on how this power is transmitted over a very long distance, because if I ask you, where is this power generated, you're not going to generate the power outside your house. No, obviously these power generating stations are at a very large distance from the commercial, from the city areas. And if you are generating the powers at a very large distance, you need to transmit it, because you are receiving this power, you are using this power for household appliances at your home. So that power which is generated at a very large distance needs to be transmitted at your place. And for this very long distance transmission, the only thing that needs to be taken care of is minimization of losses. You have to minimize the losses at any cost. And that is why this relation between V and I is considered, right? I guess I'm very clear. Chalo. Now let's move ahead. You have generated the power at 11 kV just here, but the problem is when you are transmitting it at a very large distance, over a very large distance, this 11 kV power is not a very big value. In case there is dissipation, there are losses, this 11 kV will considerably be lost. So what we do is we immediately step it up, right? What is stepping up? Stepping up means increase the power, increase the voltage. So what we do, we increase this 11 kV to 132 kV. Now 132 kV is a very large value. And how do we do this? We do this at grid substation by using a step up transformer. What is a step up transformer? You'll be studying it in magnetism, but let me just give you a basic idea. Step up means you are increasing the voltage value. So what actually happened? You generated it at 11 kV and you immediately stepped it up at 132 kV. Where? At grid substation. Now this 132 kV line is, this power is transmitted. Now you can clearly see that this transmission takes place over a very long distance. When you travel through highways, you see wires that are placed at a considerable height, those thick wires. These are those wires which carry 132 kV voltage. It's a very high voltage, and you cannot run these wires in residential areas, right? So you have generated it at 11 kV, you have immediately stepped it up to 132 kV, and then you have transmitted it over a very long distance. Once they have been transmitted over a very long distance, the next step is to bring the voltage down. Why? Because 132 was a very large value. So how do we bring them down? We bring it down through the help of a step down transformer. And where is this stepping down done? It is done at main substation. So from 132 kV, we step it down to 33 kV. Now again, a very basic question might arise, sir, why 33 kV? See, 33 kV is a standard in our country. This is the rated power that is supplied to heavy industries like automobile industries, right? Petroleum industries, they need separate power supply because the machinery that they drive, they require very high power. So this 132 stepped down to 33 kV. One of the 33, some part of this 33 kV is given to heavy industries. And what happens to the other part? This 33 kV is further stepped down to 11 kV, where at intermediate substation. Now just see, you generated it at 11 kV and finally you stepped it down to 11 kV. Now the circle is complete. Again, I'm coming back to the same question. Sir, if I had to use it at 11 kV, then why did we step it up? I guess now you understand the answer. We stepped it up because we needed to transmit it over a very long distance, right? If 11 kV was transmitted, the losses would have made it very less. See, we wouldn't have received 11 kV if 11 kV was transmitted. So what we did, we stepped up, we stepped down. So a very basic question, which sort of transformer do we use in power transmission? We use both transformers. At grid substation, we step it up, and at main substation and intermediate substation and at city substations, we step them down. So we require both the transformers. Now this 11 kV, some part is given to the lighter industries, right? Very basic industries, they do not require very high power, right? And the other 11 kV is sent again to city substation, where it is stepped down to 220 volts. Now all our appliances are designed to operate at 220 volts. अब आपको समझ में आ रहा होगा why 220 volts, right? Because 220 volts is a standard. You will never find an appliance in your house rated above 220 volt. Okay, but that doesn't mean that if the voltage fluctuates, the appliance won't work. You have different electrical circuits to manage it. We have already discussed it in electrical circuits, right? If you have not watched the sessions, there is a video on the channel where we have discussed the important board questions. Just go through it, right? So let me just summarize it up. through this basic diagram. This is the basic diagram. This, we started at 11 kV, then 132, then 33, then 11, then 220. Now for those who are visiting our channel for the very first time, whatever I have told you, whatever I have said, each and everything is written in the slide, right? Each and everything with all the proper explanations is mentioned here. Just pause the video, read the slides, and if you want to get the soft copy of the slides, the contact details are in the description box. You can contact me, I'll send you the PDF, or you can download our app on Play Store. It's KK Avasthi Edu Hub, where you will find all the notes free, right? Chalo. Just pause the video and go through it. Now these are the important questions for board exams. What is the need of stepping up the voltage from 11 kV to 132 kV at generating station? Now I guess you are in a position to answer it. We need to step it up in order to efficiently transmit it over a very long distance, because at 11 kV is a moderate value. At 11 kV if you'll be transmitting, the losses obviously will be, you need to minimize the losses. That is what has to be taken care of, right? Second, which devices are used to increase and decrease the voltage? Obviously step up and step down. Now this is a very important question. Why we prefer alternating voltage over direct voltage in power transmission? Now this is a very obvious question and it's slightly different. See, you can increase and decrease an alternating value, but for direct value you cannot increase or decrease it periodically. DC or direct current, it doesn't increases or decreases periodically. So this step up and step down facility is not available in DC. And one more thing that you will understand later on, transformers don't work on DC, right? Just note it down. Transformers work only on AC. You need alternating current if you wish to increase or decrease the voltage subsequently, right? So that is the reason why we use alternating voltage instead of DC voltage. Now the power has reached to the consumer at 220 volts. Now the next step is to use this power, use this electricity for our domestic purpose. So how is it done? There are three types of wires that we use in electrical connections. First is a live wire or a phase wire. See, I have mentioned the colors. It is either red, old convention is red, new convention is brown. So a live or a phase wire will either be a red colored one or a brown colored one. Then you have a neutral wire, either black or light blue, and then you have a earth wire, either green or yellow. Now let me just brief you about the functioning of these wires. This is very, very important. See, live wire or a phase wire is basically used to carry the current, right? This is the main wire where the current is moving. What is neutral wire? Neutral wire is used to complete the circuit. See, if I'm saying that the current is moving this way and I'm not providing a return path for the current, the circuit will not be complete. The current always flows in a closed circuit. We need to close the circuit. We need to provide a return path for the current as well. And how do we provide this return path? This return path is provided through a neutral wire, right? So a live or the phase wire provides a one-way path for the current through which the current enters the circuit, and this neutral wire provides a feedback path, a return path. And why is this earth wire used? Obviously this is used for safety purpose. In case there is some excess current, this excess current is bypassed through earth wire. We will be discussing the essential components of household circuit in the second lecture, where I'll be properly explaining you the entire concept of earth wire. Now one thing is to be noted, earth wire and neutral wire, they are at same potential. Now if two wires are at same potential, what is the potential difference between them? Obviously the potential difference is zero. They can ask this question in MCQs. What is the potential difference between neutral and earth wire? And this live or phase wire is always at 220 volts. Whatever potential we have generated through transmission, see, we generated 220 volt. This current, this is live wire, that will be carrying forward the current, the potential that we have generated. So this live or phase wire is always at 220 volts. Now 2-3 basic questions arise. What is the potential difference between live and neutral? See, neutral is at 0, live is 220. So potential difference is 220 volts. What is the potential difference between live and earth? Again, earth is at 0, neutral is at live is at 220, earth is at 0. So potential difference is 220 volt. What is the potential difference between Newton and neutral and earth? It is 0 volt, because both of them are at 0 volt, right? These are the colored combinations, color conventions rather. Old convention and new convention, you have to learn it, because they directly ask you the color as per the new and the old convention. So you have to learn both these values, right? Is that very, very clear? Now, whatever I have just told you, I have written them in the slide. The zero potential of the neutral wire ensured by connecting it to the earth wire. The neutral and the earth wire, they are connected together, and the ground, live and neutral, is 220 volts. I've already told you. Now let's see what happens when we receive 220 volt from the city substation. Now this is the most interesting part. Now we'll see how we receive 220 volt at our house. See, 220 volt has been generated at the city substation and it is sent for the consumer. What happens next? See, you can clearly see three wires: live, neutral and earth. This is how the power further reaches the electric pole. These electric poles are situated outside our locality. These electric poles have a company fuse. Right? What is a company fuse? A company fuse is a fuse circuit which is accessed only by the persons from the electricity department. We cannot access these fuse. Okay? And they have a set rating. Depending on the load, we'll be deciding the rating of these cable fuses. Normally, 50 ampere is the reading if you are operating for a 10 kilowatt load. Okay. What is the basic functioning of a fuse? Although we'll be discussing in the next session, part B, but let me just brief you. A fuse is a protection circuit. It protects your circuit from overheating, short circuit. Whenever some excess current is drawn from the circuit, this fuse wire blows out and the circuit breaks and the current cannot move further, right? So this is the basic function of any fuse wire. Doesn't matter where are we using it. If it is a company fuse used just after the electric pole, again the basic functionality will not change, right? Now you can clearly see that a live wire through company fuse, then you have that neutral wire, and then you have that earth wire, right? These three wires were coming. The live wire passed through the company fuse, and the neutral wire, it is coming directly. No fuse through neutral wire. Remember this. After the wire is passing from the electric pole, you have not placed any fuse on neutral wire yet. You had a fuse, a company fuse, which you could not access. It was accessible only to the officials. So live wire through company fuse and neutral directly, it reaches your electric meter. We call it kWh meter. What is kWh? Kilowatt hour. Energy का unit है, energy consumption. And wherever you have your meter, you can check it in your houses, you can check it in your flats. There is a proper earthing facilities. Whenever the foundation is laid for any flat, any bungalow, any house, they have a proper provision for earthing, and that earthing is done exactly at the place where you have planned to put your kWh or energy meter, right? So this earthing is very, very, very important. And what does this kWh meter do? It measures the consumption of energy, right? At this particular point, we call it local earthing, right? Appliance ka earthing we'll be discussing in the second part. This is called local earthing. So again, there is a question they might ask you, what is local earthing, or local earthing is done at which point? So it is done at the point you have placed your energy meter, your kWh meter. Is that very, very clear? Right? Now you can clearly see two wires come out. This earth wire is not connected to the next part, that is your main switch. Again, a very important question. A main switch has no connection with earth wire, but this is the first and the only fuse. Obviously, main switch is also a fuse circuit, a circuit breaker. This is the only part where a fuse is connected to both live and neutral. See, there was no fuse at neutral. Fuse was only at the line or phase wire. But main switch is the place where both the live and the neutral wires can be cut off through proper fusing. Am I very, very clear? I have already highlighted this point. Main switch disconnects both live and neutral wires. See, once you have disconnected both the wires, you have disconnected the return path as well. In case, because of any electrical fault, short circuit, or maybe a two live wires touched each other and there was a supply in one of the wires, the return path is not present. Why? Because the main switch is already disconnected. I guess all of you can relate to this. When I'm not sure about you guys, but when we used to go out on vacations, our parents used to tell us just disconnect the main switch, right? It's placed outside the connection, or maybe just on the outermost door, and when you leave, you just put it off, right? It How many of you can relate to this? In case yes, please tell me in the comment section. क्या आपके पेरेंट्स भी कभी बोलते हैं कि जब जाओ बाहर तो फाइनली मेन स्विच बंद करके जाओ? In case yes, I'll be waiting for your comments, right? Okay, after main switch, what happens? Now this live earth and live neutral and earth, now they reach the distribution box. Now this is the distribution box from where all the further connections will be made, right? Is that very, very clear? Now this is very important. This is different from what is written in Selena, but I'm sure you'll be able to relate with it. See, from distribution box, I have mentioned that there are two lines. One is a 5 ampere domestic line, and then there is a 15 ampere high power lines. All those students who are residing in maybe a 10, 15 or 20-year old house, जिनके घर अभी नए बने हैं, they cannot understand, but they can relate. They can also relate it. See, when you use air conditions, there are separate switches for air conditions. You cannot use an air condition from a normal switch. Am I correct? You cannot use an air condition in a normal switch. You can check it out in this here. You can see there is an air condition, and then there is a separate switch, right? That is a 15 ampere switch. You can clearly see it, air condition, stabilizer, and above that you can clearly see a 15 ampere switch, isn't it? So we do have these high rated switches running. Why is it required? Because the 5 ampere domestic line cannot bear this high current. So from distribution box you have two wires. जिनके घर में विंडो एसीज इंस्टॉल्ड हैं, पुराने घर हैं, जस्ट रिकॉल दिस, आपका जो इलेक्ट्रीशियन आया होगा उसने एसी से वायर ले जाके सीधे मीटर पे कनेक्ट किया होगा. लाइक इन केस ऑफ माय हाउस, इट्स अ ओल्ड हाउस, so we don't have those sockets running. So what do? We take a separate line from the air condition and we directly connect it at meter. Why at meter? Why at the main distribution box? Because we need 15 ampere. We cannot run an AC. We cannot run a heavy machine on a 5 ampere line. I guess I'm very, very clear, right? So from distribution box, please remember this. From distribution box, there are two lines running. One is a 5 ampere line and the other one is a 15 ampere line. You later on understand where does this come from, right? So what are the basic points that you need to remember for your board exams? Main switch ko we also called ECLB, earth leakage circuit breaker. Okay. Now one thing, I have just, this is the main diagram. This is your distribution box, and यहाँ पर you can clearly see this is live, this is earth, this is neutral, and for every live wire you have used a fuse, right? You can clearly see you have used a fuse. इसके आगे इट डिपेंड्स कि आप घर में पावर को कैसे ट्रांसमिट कर रहे हो, कैसे चला रहे हो. दिस डिस्ट्रीब्यूशन बॉक्स it connects everything, but the question is how are these connections made. The distribution box say how does this wire move. So in our houses we use ring system, but before telling you ring system I want to tell you about the system that we used to use earlier we used a tree system. What was a tree system? In tree system there was a single point where all the 5 ampere 15 ampere lines were there, and whatever connection we required we used to directly run a wire and take that connection from the distribution box. What was the problem? The problem was, मान लीजिए मेरे यहाँ 5 appliances हैं and I need to incorporate 2 more appliances. What do I need to do? I'll have to put those appliances and run a separate line. कहाँ तक? Till the distribution box. Why? Because I was using a tree system. A tree and a lot of branches. I guess you can relate with it. A tree and a number of branches. Each branch is connected to a single system. That was a tree system. But now we use a ring system. Now what are ring systems? Ring systems, you have wires running around your rooms. If you're watching this session, just look around your room, you will find small sockets embedded in the walls, right? So all live, neutral and earth wires are running around your room. What is the advantage? For example, I need to incorporate or I need to use one more switch. I want to use one more appliance. Do I need to connect it to the distribution box? No. All the wires are running around my room. I can simply take a connection, right? I'll show you one of the boxes. I hope it is visible. आप अगर देखोगे तो rod के ऊपर you can see a small box, right? That is a box, and these are the wires that are running. Now in most of the cases these wires are concealed, so we are not able to see it, right? But अगर किसी का बहुत पुराना घर है तो you'll find those wires running on a rubber strip. There are rubber strips on which these wires run, and you can clearly see 3 wires: live, neutral and earth. इन बहुत पुराने घरों में, आई गेस 50 साल से पुराने जो घर होंगे और जहां वायरिंग नहीं चेंज होगा, या किसी पुराने गवर्नमेंट बिल्डिंग में आप जाओगे तो आपको अभी भी you will see those rubber pads in which 3 wires are embedded and you have taken the connections. आपके घरों में भी वैसा है रिंग सिस्टम में, बट दे आर कंसील्ड, ओके, विद इन द वॉल. बात समझ में आ गई? बट व्हाट आर द एडवांटेजेस? Just see the connection. You get questions on this. You had a lamp, so how was it connected? This yellow colored wire is the live wire. This blue colored wire is the live wire. You have connected one end through the live wire and you have used a switch and a fuse. That is optional. Obviously that is optional. If you wish to use you can, if you don't wish to use you cannot. You can avoid it. But using a switch and a fuse for every appliance is an advantage in ring system, and obviously the other end is connected to the neutral wire. अभी गलती कहाँ होता है? This is a socket. A socket has 3 pins: earth, neutral and live. So whenever you are drawing this ring system, don't forget to connect this wire. Just let me just help you. This earth wire with the earth terminal. In none of the other cases you have connected a earth wire, but if you have a 3 terminal socket you have to make connections for the earth wire as well, right? Later on I'll be taking a session live on YouTube where we'll be discussing only the question part, but before that just remember these basic things. इस केस में भी आप देख सकते हो, they have used a switch, they have used a fuse. Again tell me one thing, स्विच पहले यूज करोगे या फ्यूज पहले यूज करोगे? ऑब्वियसली आप पहले स्विच यूज करोगे फिर फ्यूज यूज करोगे, इजंट इट, राइट? तो ये सब छोटी छोटी चीजें ध्यान रखना, बिकॉज यू गेट क्वेश्चंस ऑन योर बोर्ड, इन योर बोर्ड एग्जाम्स, राइट? तो जो मैंने अभी आपको समझाया इट्स रिटन इन द स्लाइड्स. यू कैन जस्ट पॉज द वीडियो एंड गो थ्रू इट. जस्ट रिमेंबर दिस वैल्यू 30 एम्पियर्स. यहां पर जो एमसीबी लगा हुआ है, दिस वन this. The rating is 30 amperes. Okay. Advantages I've already told you. You can use a separate fuse. You can plugs and sockets depending on this. A new line is not required. Now this is very important. This is the first point mentioned in Selena, but they have not given any explanation. For the connection of every appliance, you have two alternate paths. Let me just brief you. Suppose you wish to connect a lamp. This is one path and this is other path, right? So this system facilitates you with two parallel paths for the interconnection of every appliance. In case there is some wear and tear, some problem, you can alternatively use the other path. So this is one added advantage, right? All the others are very basic. Now the other question, how do we connect appliances in our house? So we use parallel connections. It's a very basic question. Why do we use parallel connection and why not series connections? I've already mentioned it. See, let us discuss the disadvantages of series, but before that, let us understand the advantages of using parallel connection. See, in parallel connection, the voltage is same. I guess if you're watching this video, you have already completed electrical circuits. In parallel, we know that voltage is same. In series, we know that current is same. So if we are using a parallel connection, that means voltage is same, right? And the current is divided, right? And the current is divided. Let us assume that one of the appliance is not working. So that's perfectly all right. The current was divided. No current is flowing here, but the current is flowing here. So the other two appliances will work. But अगर मैंने इनको सीरीज में लगाया होता, for example मैंने ऐसे सीरीज में लगाया है, and one of the appliance is not working. If it is not working, the circuit is broken and the current will not move in 2 and 3. So nothing will glow. If these are 3 bulbs, none of the bulbs will glow. So fault tolerance is better. Fault tolerance is a appropriate word. Okay. What are the other disadvantages that we have in series? See, in series, the current is same, but the voltage gets divided. So if you are using, say, two appliances and you have received 220 volts, so 110 and 110 will be separately used by the two appliances. And as you will be increasing the number of appliances, the voltage will be dropping. See, the voltage needs to be divided amongst the appliances in the ratio of their resistances, right? So greater up the number of appliances you are using, lesser will be the voltage across each appliance. So all of them will not glow. If you are using a, say, 10 20 watt bulbs, all will not give you the same brightness. You're getting my point, because you will be having other appliances as well. So this is one major disadvantage, right? So this brings us to the end of the first part. I hope all of you have enjoyed the session. In the next part, we are going to discuss the different elements that we use. So if you're new on the channel and you have found the content interesting, don't forget to subscribe the channel and click the bell icon so that next time around when I come live or whenever a lecture is live, you are notified. And on the channel, you have a lot of videos related to all important questions, right? So let's catch up very soon with other session. Thank you very much.